Yeah, about 10 seconds, just so you know. If you have an answer, just put it down. Okay, that's loud. Okay. I'm going to end that real quick. I'd like to see, and this is my first time doing this one, see if I can share the results. I can't see the results, so that'd be nice if I can see them. Okay. So I'm trying to see if I can open these. Okay, I can see them. All right, so what I'm going to do, give you the answers real quick, and then I'm going to show them. I'm not sure if you can see my screen right now or not. If you can, I'll be able to actually bring it up here in just a second. So number one, as we look at number one, what you should have gotten on that one is 39. Number four, you should have gotten 83.3. That's for number four. Number seven, the answer is 50. Again, I'll put the work up in just a second. And then number 11, you should have gotten 30. So I'm just kind of looking through some of the answers that you may have gotten to kind of see how we did. And then what I'm going to do is here, I'm going to share my work. So hopefully that's up now. Let me know if it's up real quick. Someone can just let me know, and then I can start scrolling through. Okay, cool. All right. So number one, what is? So you're saying what is? So that x equals comes from the what is. 26% is where I got the 0.26 of 150 is times 150. All those words kind of match up. Now, if you got any of these wrong, I'm going to try to go through quickly, but I don't want to waste your time. I don't want to waste your time, but I don't want to go too fast. You know what I mean? So kind of write these down as I'm scrolling through. So that's number one, what you should have had. Number four says 25 is, so 25 equals. 30% is where I got my 0.3 from. Of what number? So times x. And the number part, you could have, I guess that the word number doesn't really matter. You could just say 30% of what. So the number is just part of the what. It's a variable. Okay, so 25 equals 0.3x, and then you just divide both sides by 0.3, and you get your 83.3 on number 4. Number 7, 17 is, so and first off, just you're looking at my work, anything I've in red is the original equation, the blue is the stuff I did when I was actually trying to solve the problem. So look at the red, that tells me what was originally there. So 17 is, so 17 equals what percent, so what percent, I kind of like to put those together, so it's x divided by 100. So that's the what percent of means times 34, so times 34. So what you'll see on this one is I multiply by the reciprocal. I kind of thought of the 34 on top, the 100 on bottom. I kind of treated it as if it was the following equation: 17 equals x times 34 over 100, because that's the same as if you put the 100 over there. It's just interchangeable when you're multiplying. So I multiplied by the reciprocal and got my answer from there, which was 50. Okay, that's number 7. And then the last one, I believe, was number 11. Now, it's not all of you got here, but I'll kind of walk through it. What I did on this one is you take like a word problem. This is a little bit of a transition into an SAT type question where you are going to have to kind of take these words out of an actual sentence. But he said, Joe made enough dinosaurs for 75% of his class. And he said there are 40 students in Joe's class. How many dinosaurs did he make? So what you're doing, you're kind of looking at this problem. There's 40 students. He only made enough for 75%. So you'd be like, well, what's 75% of 40 then? Just kind of, if you ever catch yourself like asking yourself that question, like I need to figure out what 75% of 40 is. Well, you're using those words so you can make an equation out of it. So it's like, yeah, what is 75% of 40? Oh, wait, what is 75% of 40? I can make an equation. And you write that out. So that's what we're asking to do. So I said x equals, that's what is. 75% is 0.75 of 40 is times 40. You multiply it, you get your answer. Okay, so that's part of the homework. As you can see, some of the other answers up here as well. I want you to practice these using these skills. What you'll notice is a lot of these are connected. I try to get them to slowly build. there's certain types of questions, like the first three are almost the same type of question, the next three are almost the same type of question, and you kind of see some similarity there, but it gives you some repetition. Okay, so we have that. Remember, don't do page 16. What we're going to do now is we're going to jump down to the next section on rates and ratios of conversions, and I'm going to do a quick thing on page 17. This is honestly like the last one today, that set of problem I'm going to do today that is not in the gray box. Like this one's not in the gray box, but probably should be. But I'm going to work through these first four. Now, a couple of these might be fairly simple, and actually I need to scroll back to my other one that's blank. There we go. So right now I'm on page 17. I'm going to do number 1. And I'm just going to kind of walk through these real quick to understand how to solve proportions. Now this lesson is on rates, ratios, conversion. And a proportion, just so you know, is actually just two ratios. So this is really going to fit into this section anyway. So I'm going to walk through these just to make sure you know how to solve a proportion. So for the first one, if you're solving a proportion, we use this concept. It's called the cross product property. And all we're really doing is we're cross multiplying. And you may already know this, you may not, you may already know it, but this is going to lead into, like, this skill is going to lead into what we're about to do in this lesson. It's dealing with conversions, things like that. So I'm going to cross multiply. What that means is I'm going to cross multiply the x and the 91. So I'm going to go 91x. I'm also going to cross multiply with the 7 and the 39. So I'm going to multiply those as well. And 7 times 39 is going to be 273. And now I don't have a fraction. All right, so I've gotten rid of my fractions. Now I'm going to go ahead and divide both sides by 91 to get the x by itself. And see if I get a nasty looking number or not. I don't. So x in this case would be 3. And so that's just a basic proportion. There's nothing really, I would say, too complex about that one, other than the numbers being big. Number 2, this is going to show up a little bit in geometry with what's called geometric means, but it's still a proportion, and that's how I usually like to talk about it. Even when we're doing geometric means, I want to talk about proportions. So you'll see this pop up a little bit more later on, but this is just the basics here. Just solve. We're going to solve it the exact same way, which means we're going to do cross product property again. Here I'm going to multiply x and x. When you multiply x and x, you get x squared. Over here, we're going to multiply 1 and 9 and get 9. There's your cross product property in action. At this point, I'm going to square root both sides. Technically, I would get plus or minus 3, just so you know. And because of this case, it could I guess in this case they could be negative. I will put plus or minus 3. I don't want to kind of have you forget that. But when you're square rooting a number, it could be plus or minus, because you're asking yourself what number times itself gives you 9. 3 times 3 gives you 9. Negative 3 times negative 3 also gives you 9. So if you think about plugging them back in here, if I have 1 over negative 3, that would equal negative 3 over 9. They both be negative, and they simplify to 1/3. So that would be plus or minus 3 on number 2. Okay. Number 3, doing the same thing again. Do some cross product. Here I'm going to cross multiply here, but I have a binomial in my numerator, my second fraction. So I'm going to have to use distributive property on this. So I'll write that up as 5 times the quantity x minus 2. Over here I multiply 3 and 4 and I get 12. So we're just going to do distributive property and solve. So I have 5x minus 10 equals 12. Now I'm going to add 10 to both sides. I'm going to solve for x. This one won't work out as pretty, but oh well. Here I get 5x equals 22. And finally, I'll divide both sides by 5. And that would be, well, just be 22/5. You can probably leave it that way. Or I can say it's, let's see, 5 goes into 20 4 times. 2/5 is 0.4. You can use a calculator if you wanted, but 4.4 would also be an answer on that one. So like I say, these first 3 are pretty just standard proportions that you're going to see on the test, and as we work through other lessons, they're just going to pop up. When you're solving algebra equations, you're going to see this as well. This next one will kind of lead into what we're doing in this lesson. Now, what you'll see with this proportion is that our units aren't exactly the same. We're going to do a little bit of conversions, because if we're dealing with a proportion and our units aren't equal, we can't cross product and all this stuff. So, for instance, what I mean by that is if I have miles on my left-hand side for the numerator, I have to have miles on the right-hand side for my numerator, or vice versa. I'd probably do the vice versa on this one because I got x feet. I don't want to mess with that. So what I'll do instead is I'm going to take this miles and I'm going to convert that to feet. Now what you'll need to know is that in 1 mile, that's going to equal 5,280 feet. Now they do test conversions on the SAT, so this is one that you'll need to know. A lot of people tend to forget this one. Some other ones are a little easier to remember, like 3 feet is a yard and 12 inches is a foot and stuff like that. If it's a really one that's kind of hard to learn, like how many kilometers are in a mile or something like that, they'll give that to you. Otherwise, if it's more one that you're supposed to know, you just got to know it. Okay, so 1 mile is 5,208 feet. So this one, what we'd have to do is, I'll just do it up top, we're going to go 3, because there's 3 miles, times 5,280. So 3 times 5,280 is going to be 15,840. I'm going to replace that with 3 miles. So that's my new numerator. Okay. On bottom, I have 1 minute or 1 hour, and this one I'm just gonna let's just fix the this left fraction. Just to kind of focus on that. My camera's, I think I keep going off screen, so it wants to refocus. Hopefully I fixed it. Okay, for 1 hour I'm going to go 60 minutes. So that way I have feet minutes and feet minutes. So I can do my cross product at this point. So now that we have the units the same, we're going to cross multiply here. So 15,840 times 1 is 15,840. Don't worry about the units at this point. As long as the units match up, we're okay. So they match up, and I'm not going to worry about them now. Here I have 60 times x, not 1, I crossed that out. So that's going to equal 60x. So I have 15,840 equals 60x. Now I'm just going to divide by 60. And it's going to be 264. Now in this case, the 264 represented the feet, so that's what this would equal. So that's really proportions in a nutshell. What we're going to do though is we're going to take this premise, like this was a more simple, I'd say, conversion. We're going to try to do some harder ones if we can, and that's what's going to show up on this next page. If we want to scroll over here to page 18, now remember, at any point if I'm going through things, if I'm going too fast, you have a question on something, type it up real quick, and I can kind of go over them as I'm working through this. So just kind of keep me up to date on all that. So on page 18, we're going to do a little bit of conversions. I'm going to show you conversions as I work through it, so I'll kind of teach it as I do it. But I'm going to solve or do conversions through things called conversion factors, which means I'm going to multiply by a ratio. So you'll see what I mean as I go through this. So the first one we're going to do, I'm going to do a conversion. I'm going to convert 20 feet to miles. But I'm going to do it using a conversion factor. So this is one of the simpler ones. You may not even need a conversion factor for this. There are some ones where the conversion factors are very useful, but the reason why I do conversion factors is because they always work all the time. Sometimes I get some pushback from students saying that I was able to do this conversion without using the conversion factor. I'm like, that's cool, but the conversion factor would have worked, wouldn't it? And when we get to the harder ones, maybe your method wouldn't be so hot. So anyway, we want to practice conversion factors. Even if it's an easy one, you should be able to do it all the time. It should always work. So first one, convert 20 feet to miles. What I'm going to do, I'm going to do in a conversion factor. First thing you do, write the original number that we're trying to convert down. And if you want, you can even put it over 1. It depends. You don't have to, but we are going to be multiplying by ratios or fractions. So sometimes it helps to kind of see it in a fraction form. So I have my 20 feet. Now I want to convert that to miles. So what you do is you are going to multiply by a conversion factor. So what the conversion factor is here is the following. I know, you should make sure you remember, don't scroll back to the previous page when we wrote this down, I should know how many feet are in a mile. So I know that 5,280 feet represent 1 mile. What I'm going to do is I'm going to put this in a fraction format, and I'm going to write it the following way. I'm going to say 1 mile over 5,280 feet. Now, if you understand how fractions work, what I've just done is I've multiplied 20 feet by 1. If you don't see what I mean by that, don't write this part down. It'll just kind of look confusing. 5,280 feet is 1 mile. Okay, sorry, I'm back. I need to share my screen again real quick, so give me 1 second while I load that up. And I'll try to explain what happened, but I need to get this all started first. Alright, so I have that up. One sec, one more thing, and I'm ready to go. Zapier, I have to bring up an app to share my iPad, so I'm just bringing that app up right now. Okay. You're about ready. All right, we good? Hopefully. Okay, cool. So basically, what happened there, and I think I'm gonna just go ahead and get a new video card. Every once in a while, and it's like once a week. Of course, it's gonna happen while I'm doing the class. Maybe it's because I have multiple things up at once. My screen just goes blue, and I have to restart the computer. So if that happens again, I'm just going to reload. It takes just a couple minutes. Hopefully it won't happen again. I hope. That's what happens the first time I have a class. So I'm going to get a new video card. I think that's the problem. Anyway, I was in the middle of this question as we were going through. So where I was talking about how technically I'm multiplying by 1. And this is why. 5,280 feet is 1 mile. So if I want to kind of rewrite it, I'm technically multiplying by 1 over 1. But what I'm able to do by putting it in this format, with 1 mile over 5,280 feet, I can convert. And I convert using just simple math. Here's the deal. If you have feet and feet, notice how I wrote this. I did not put the feet on top because now I can cancel your units. Feet are going to cancel. So I just went from feet to miles. All I have to do is kind of combine these two fractions. So what you'll see here is I'm just going to go multiply fractions. I'm going to go 20 times 1 is 20. And now the only units is miles. You'll see that when I'm done. Over 5,280. So you divide those two. And my calculator is even freezing on me. I'm sure you can. Literally, my calculator is not wanting to work. So yeah, there's my luck. But I can use my phone, I guess. Everything wants to break at once. That's how things work. Calculator 20 divided by 5,280. I'm going to get a crazy fraction, or decimal, I mean, is 0.00378. So that's going to equal 0.0037. I'll just go 379 because I'll round that last decimal. And in this case, it's going to be miles. So that's a basic conversion factor. You just need to multiply by a conversion. You just put it in fraction form. So if you know the conversion, you just put it in a fraction form. Make sure you line it up so the units cancel, and whatever unit is left over is going to be your new unit. So if I'm going to try this one more time, I'm going to do 4 inches to yards. So I'm going to start, first step, I'm going to write 4 inches. And if you want, you can put it over 1. That's fine. I'm going to convert to yards. Now this one, you may not know how many yards are an inch, how many inches are in a yard. So we can do it in 2 steps, and that's okay. It doesn't matter how many things you multiply by. So in this case, what I'll do is I'll say, hey, I know how many inches are in a foot. But when you write this conversion out, put inches on bottom, feet on top by default. I know 1 foot is 12 inches. I'll just multiply by 1. Remember, technically 1 foot over 12 inches is 1. Next, I know how many feet there are in a yard. Now, kind of get an idea where we're at right now. The inches are now gone. Okay, so I'm trying to get rid of my feet now, and I want to be left with yards. So I know that there are, in 1 yard, there are 3 feet. Again, notice the way I wrote that. The feet have to go on bottom. If they don't go on bottom, they're not going to cancel. So I'm going to cancel now my feet. Now, if you knew how many inches there were in a yard, you can write one conversion factor. You can sometimes even do that in your head, but you don't have to. You can do it as 2 separate. So if you look, the only unit left over is yards. Okay, so as I write this out, all I need to do is multiply all my numbers. Notice on top, I have 4 times 1 times 1, so that's 4. On bottom, 1 times 12 times 3, so that's 36. And by the way, because I'm left with yards, this is in terms of yards. I simplify that. Calculator's still not working. Okay, whatever. So 4 divided by 36 is 0.1 repeating. That makes sense. It's 1/9. You put a bar over or 0.1, depending on, you know, if you're doing the test, how much they wanted, how many decimal points they wanted. But it's 0.1 yards. And those are, you know, kind of simple conversion factors. When I say simple, you know, it's new. Sometimes if it's new, it takes a little practice to get used to, but those are the basic ones. And then they kind of build from there, and that's what I'm going to go through in these next examples. So again, as I go through, if you ever have a question, you just got to stop me, because I'm just going to keep going until you ask a specific question. So I'm going to go on to number 7. Number 7 is dealing with a rate, but it's rate in terms of certain units that you'll see. This one says a cyclist travels 105 kilometers in 4.2 hours. Now what we're going to do with these, we have 2 units. Now what I'm going to do with this one, I'm going to write this as a ratio. It's 105 kilometers per 4.2 hours. For example, before I even kind of go any farther, this is just to kind of avoid any questions I might be getting. If you are ever told, if you're driving a car and you're going 25 miles per hour, that's a rate. Well, the word per, which you'll see here, I'll actually be doing it here in a second. I'll even go ahead and write this one down since we're doing it here. The word per means divide. So for instance, this would be 20 miles per 1 hour. And it's just a rate. You're going 20 miles in 1 hour. That's what I'm doing on 7. I'm going 105 kilometers in 4.2 hours. So it's 105 kilometers per 4.2 hours. Okay, so whenever you see any type of rate in that format with time and speed and whatnot, just write it as a fraction, whether it has a per or not. But per does mean divide, so you can always do that. Okay, so that's my rate. I need to convert this. They're just telling you to. Convert it to miles per minute. So we have 2 conversions we need to do in this problem. I have to convert kilometers to miles, and I need to convert hours to minutes. There is one conversion that I really want you to know, because it just seems to show up a lot on the test. I want you to know this. And this won't matter on this problem, but I'm going to give it to you anyway. You'll need it here in just a second. There are 3,600. That's not looking too good. There are 3,600 seconds in 1 hour. Again, you won't need it here, but you'll need it on the next one or next 2 or whatever. So just know that. Okay, write it down and then kind of get that in your head. It's going to save you time later. All right, but in this one we won't need it anyway. Okay, so we convert kilometers to miles, and that's kind of tricky, but notice they're giving it to you, so we already know this conversion. So I'm going to go ahead and write that out. Notice when you write it out, I have to cancel kilometers. So the kilometers have to go on bottom. So I'm going to multiply this by the conversion factor. 1 mile is, or over in this case, 1.61 kilometers. And again, what's happened? Kilometers are going to cancel. Now I'm in terms of miles. I want to be in terms of miles. The next thing I need to do, I need to get the hours in terms of minutes. So I know that there are 60 minutes in an hour. So I'm going to put 1 hour on top because I want it to cancel out with my other hours on bottom. And that's 60 minutes on bottom. So you'll see that the hours now cancel. So what I now have, I have miles per minutes. So however many miles per however many minutes. That's what I wanted. So I'm going to now multiply everything. I'll go 105 times 1 times 1, which is 105 miles. On bottom, I have 4.2 times 1.61 times 60. So that one, yeah, I need some help. Okay. So 4.2 times 1.61 times 60 is 405.72. And you can always welcome to check these as I go through, because if I ever like accidentally like type something wrong, I'm going to need you to save me. So feel free to always check my work. This one, it says I want miles per minute. So what I'm going to do, I'm going to go ahead and just divide this 105 divided by 405.72, and it's going to give me 0.2587. I'm going to call it 0.259. And technically what I've done is I've taken that number and I made it into a whole number in a way, so I can decimal whole number. Technically this is over 1. Right? Well, what this is now, it's 200 or 0.259 miles per 1 minute. And when you say miles per minute, it has to be over 1. You don't have to write it that way though. Technically, you'd probably see it like this: 2.59, miles per minute. This is the simplified way you'd see it, but it's technically that. And that's kind of how rates work, if you didn't know already. Okay, rates are fractions. So that is more of a a situation where you might actually want to have conversion factors. It's kind of a little bit more useful in that case. Now these next two are actually almost pretty much the same thing. So I'm just going to do one of them. That way we can go on to the next section. I kind of lost some time here, so we're going to try to catch up. So these next two are very similar. As I said, we already started number 8. So I wanted to do this one so you can at least see another example, because this is a little trickier. And I have 20 miles per hour. That's how fast this go-kart's going. Very simple question in the sense that they're telling you exactly what to do. Convert this speed into feet per minute. So I want to convert feet per minute. Now you notice the only thing, let's see, this 1 hour is 3,600 seconds. That's what I would be using on number 9. Otherwise, it's basically the same question. So, if you want to see when that 3,600 seconds equals an hour would have shown up, it would have shown up in number 9. Anyway, what we're going to do is convert to feet per minute. So I have my miles. I'm going to start. Oops. That's my phone. Sorry. Okay, so I'm going to start by converting my miles to feet. And you don't have to start with miles to feet. You could go hours to minutes. It makes no difference whatsoever. You're going to multiply it all out when you're done anyway. But I'm going to go miles to feet. So I know, in this case, yep, I'm going to feet. So I know I'm going to put miles on the bottom because I want the miles to cancel. And so I know 1 mile is 5,280 feet. So that's my first conversion factor. And again, the nice part here, miles cancel. I'm now in terms of feet, which is what I want. Next up, I have my hours. I'm going to convert that to, they said minutes, right? Yeah. So I'm going to go 1 hour on top is 60 minutes. Again, the order matters because I need to make sure that these hours cancel, which they do. And I'll keep it blue. So on top, I multiply. And really just forget the 1. It doesn't matter, right? On bottom, 1 times 1 times 60. I'm just going to put a 60 on bottom. And I'm going to write down what I get. So here I have 20 times 5,280. So I have a big old number, 105,600 feet on top. On bottom, I have 60 minutes. And they wanted feet per minute. So I need to take that number and simplify it. In other words, just do the division. So I'm going to take that number, 105,600, divide by 60, and move it over here. I get 1,760 feet per minute. Again, that's the simplified version. You could have written it as 1,760 feet for my numerator and 1 minute for your denominator if you wanted to. I'm just skipping that step now. So conversions, those are conversions. Now again, if you have questions on these, you can always ask those. Remember too, I am recording the lesson, so we're 38 minutes into my recording, 39 minutes at this point. So you can always kind of go back and see how I solve these as we go through it. So what we'll do, and again, I can go back if you need, if you're typing something, let me know. I can always go back. I'm going to kind of jump into the next section here, working with distance, rate, and time. And I'm just going to walk you through how these are going to look. If you're dealing with distance, rate, and time, there's a formula. This is on page 19. So I'm kind of just going into the next little portion here. So moving away from conversions and moving into distance, rate, and time. So rates are still, one concept of rates are still there. This one, whenever you deal with distance, rate, and time, there's different ways that you may have been taught. I know a lot of things that I was taught in schools, like I make a little table. I don't really do that. I mean, you can if you want. I just try to keep it as simple as possible. Anytime you're dealing with distance, rate, and time, I just write out DRT. I just fill in the blanks. I don't try to make things too overly complicated here. But again, we're using this formula. Page 19. You just need to know this formula. They're not going to ever tell you this. Now, when I talk about the SAT, I talk about how to recognize this, but even when I do that, it's really not anything tricky. Even on the SAT, it's like if you see a problem that's dealing with distances and rates and times, those things are all being mentioned. I mean, you need this formula to solve it. That's what all those things have in common. I have a couple word problems. That's typically what you're going to see anyway. I kind of at least want to show you what this would look like in a word problem format. So this first one, and both of them actually they're what I call dual distance, rates, and time questions. This one has Maria and Eduardo. They're traveling to a business conference. So they're going to talk about Maria and her trip and Eduardo and his trip. So that means we're going to have two sets of distances, rates, and times. So as I write this, I'm going to label this first one Maria. And when they start talking about Eduardo, I'm going to mention his as well. So I'm going to have two sets, as I said, of two sets of D's, two R's, and two T's. I'll fill them in as I go. And then we'll see what we need to do with them and whatnot. But this one says the trip takes 2 hours for Maria. And again, as you're reading this problem, you'll see time. All right? You'll see distance, 40 miles farther. So as soon as you see two of those, you're pretty much, two of those three concepts, pretty good bet you're using distance, rate, and time, because they'll just assume that once you have two of those things, you can find the third on your own. So they don't necessarily need to mention it. So I got Maria 2 hours and 2.5 hours for Eduardo. So my time is 2 hours here, 2.5 hours here. Make sure as you write down the values, you put the unit of measure next to it, because they may say it took 2 hours for Maria and then 145 minutes for Eduardo. And then you have to know, if you're trying to connect these, like set them equal or whatever, you need to have the units the same. So we may have to do conversions on these. These you won't, but just be aware of that. So there's your times. Now for, let's see here. For Eduardo, let's see, the trip, okay, and 2.5 hours for Eduardo, since he lives 40 miles farther away. So I know that Maria, her distance, I mean, they don't really tell you anything. They just tell you her distance, or Eduardo's distance is 40 miles farther. So we're going to call this D for Maria, but this one is going to be D plus 40. It's 40 miles farther. So you just put D plus 40 for Eduardo. Next, they said Eduardo travels 5 miles per hour faster than Maria. So do the same concept here. We don't know how fast Maria goes, but we know Eduardo's 5 miles faster. So we're going to call this a rate. Let's call it R. But this would be R plus 5. So I have now two sets of equations. Now what they want their average rates. So we want to then figure out what R is. So I have, in a way, here's what I got. I have D equals 2R. That's Maria. Distance equals rate times time. Maybe I'll even call it lowercase because that's how I've written. So I have D equals rate times time. For Eduardo, it's a little different. This is D plus 40 equals rate times time. So this is R plus 5 times 2.5. Well, let's put the 2.5 in front. It doesn't matter the order that you do it in. So I have two equations. This is a preview of systems of equations because I have two equations, but I have two unknowns. So I can actually, or should I kind of say it the other way? I have two unknowns, which is normally a problem, but I have two equations. So if you have two equations, you can solve for these two unknowns. I'm going to use a method called the substitution method. I'm going to take this 2r. I know it equals d. So I'm going to take it and put it in right here into my second equation. So instead of d plus 40, I'm going to have 2r plus 40. Again, this is systems of equations. We'll do this a little bit more later on in our algebra lesson. So I'm going to go 2r plus 40 equals, and here I'm going to distribute my 2.5. So I have 2.5r, and then 2.5 times 5 is a decimal. 2.5 times 5, 12.5. Actually, I should have known that, but whatever. Okay. So now I'm going to solve for r. If I'm solving for r, it looks like I'm going to subtract 2r from both sides to keep this a positive. So that's going to give me 0.5r. Over here, I'll subtract 12.5. So that's 27.5. And then last step, I'll divide by 0.5. That's actually the same as multiplying by 2, so that should be 55. Oops. Now, with this problem, once you get the rate, that would be Maria's rate, because you see that Maria's R. Eduardo is just going to be 5 more. So I'm just going to say M. They want their average rate, so I'll say M is 55 miles per hour. Where Eduardo, which I'll just call E, is going to be 5 more than that, so it's going to be 60 miles per hour. So it's going to be your two rates. So again, dealing with distance, rate, and time, you say, why is 27.5 positive? So you're looking at that one. What I did here is I subtracted, if you kind of go back here, I subtracted 40, 12.5 from 40. So there was a positive 40 already. So 40 minus 12.5 should be positive. If I went 12.5 minus 40, it would have been negative, but I was going the other way around. Like I said, there's no trick to these. You just gotta, no problem. There's no trick to these. You just gotta write out your distance, your rates, your times, fill in the blanks, and that's what I'll do in the next one as well, and set up the equation accordingly. So normally, this is what you'll get. You'll get something like a system of equations. I try to give you one that's a little trickier for the second one. So you've seen it. I haven't necessarily seen this one on SAT yet, but I want you to be ready. So this next one, we have two planes. I don't have a ton of room here, so I'll just write small. One's going to San Diego, so south to San Diego, the other heads north to San Francisco. Got it. Okay, so I'm going to call this SD and SF, so I get my two sets here, SD and SF. Now this would be one where I probably have to read the problem to actually know it's a distance, rate, and time, but hey, it is. Well, I'm not going to read it twice. We kind of know what section we're in right now. Okay, so in this one, they're going in opposite directions. The San Francisco plane flies 50 miles per hour faster. So this is what we had before. It's going faster, so I'm going to call this R for San Diego, but this would be R plus 50. So whatever my rate is, it's 50 miles an hour faster for San Francisco. In half an hour, the planes are 275 miles apart. So in 1/2 an hour, so our time is going to be 1/2 for both of these. Well, let's call it 1/2 of an hour. I have to use 1/2 because my rate is miles per hour. I figured you would do that anyway, but half an hour. So you have to use the same type of unit. And here's the thing here. For D, we don't know what D is. But that's okay. Because here's what we have. You can call it, don't write this down. You don't have to. I'm going to call this like X and Y for right now. So they're two different variables. But here's what we have. I have a plane going this way and a plane going this way. This distance is X. And the other distance, actually San Diego, which one's what? One has south to San Diego, so make it match up. This would be Y then, that's going north of San Francisco, and this is X, that's going south. I want the distance between them. So what I'll do is I need to figure out, basically what I'm going to do, I'm going to go X plus Y, and that's going to equal your total distance. As I said, I haven't seen this one in SAT, but it would be a good question if they came up with it. So I just want to make sure that we're ready for it. It's a little tricky. But what I'm going to do in this scenario is I'm going to find X. I'm going to find X the following way. I'm going to say that X, this distance, is going to be 1/2 R. This is my X. I'm going to add that to my Y. My Y is rate times time for San Francisco. So that's going to be 1/2 R. Notice I'm using distributive property here. Plus 25. I'm basically going X plus Y. Those both represent my distances because they're rate times time. And the nice thing is I know what those two equal if you add them up because they told me. It's 275 miles. So this equals 275. So this is where I'm at. Okay. Now that doesn't give me the answer, but notice the only variable that's left is R. And what do they want? They want their speeds. So I'm looking for R. So I can solve this for R and plug it in and get my two rates. So 1/2 plus 1/2 is kind of nice. Half and a half make a whole. So that would be 1R, or R plus 25 equals 275. Very simple equation to solve. So I'm just going to subtract 25 from both sides. And R equals 250. So that is going to be one of my rates, and that's going to be the San Francisco rate, or San Diego, sorry. It's miles per hour. The other one is 50 miles an hour faster. So I'm just going to add 50 to that, and it's going to be 300 miles per hour for San Francisco. You got it. So like I said, a little trickier with that setup because normally you're used to just setting things equal to each other. You can't do that here. Is this going to be on SAT? I don't know. I mean, maybe not. But like I said, there's that. They're going to test these concepts, so there's a possibility it could be there. I want you to be ready. That's all. There's the camera. Okay. So that's your distance, rate, and time. Again, for the most part, you're going to see that first type of example. But I'm just getting you ready for everything. The test is still new. I've only seen a couple of them so far. So what we're going to do here, it's 7:23 my time. I say my time because, who is it that's in England? Is it still England? Lena, are you in England? I don't know. I'm curious what time it is there, if that's where you're at. But 7:24 here. We're gonna try to power through the rest of this. Now I do have, if I have time, what I'll be doing is I want to give you like a preview of the next unit that'll save us time next week. But we'll kind of see where we're at this point. Where I want to go now, we're going to go down percentages. We have percentages, frequency charts. I have averages, and yeah, so I think we're doing pretty good. Just want to kind of double check that. So we're doing good, but I'm going through arithmetic today. That's my goal right now. So we're going to go straight into percentages. Now, some of the things we talked about earlier today is when you deal with percentages, this phrase percent more, percent less, it's popping up again. So if you're going up by a percentage, you have to add 1 to it. If you're going down by a percentage, however, you need to see this. You're subtracting from 1. So this is new. The percent less is new. The percent more is not. Percent less is a new thing. So if I'm going down 35%, understand what we're doing is we're going to need to get that percentage, we're going to go 1 minus 0.35. It's decimal equivalent. So 65% in that case. So what that means is if my test score, I had 100% on a test, and my test score went down 30%, what's my new test score? It's 70. You're subtracting. So hopefully that kind of makes sense. Sometimes in the context of a question, you kind of forget that, and you just type in, that you see 35% less. You go, 0.35, multiply, and you get it wrong. So don't do that. Be good. Okay. So the other thing I want to talk about here, and that will kind of pop itself up here. These are SAT related questions. You'll kind of see that as we go through the SAT stuff if you're doing that portion of the class. The other thing I really want to talk about, and this is what you'll see the examples on right now, is this formula, percent change. Honestly, just know the formula. Percent change is difference divided by original. So if I'm giving you two sets of values, you're going to subtract them. That's what difference means. It means subtraction. And you're going to divide that by the first number, whatever the original number was. And it's just a formula. You plug in the formula and you get it. So this is a formula you'll need for the SAT, so it's something that, again, you want to know it. Here's an example. We're going to find the percent change. Okay? We had snowfall 18 inches in the year 2000. In the year 2016, we had 7 inches. Now you got to figure out, what am I finding the percent change of? Percent change of the years? No. We're finding percent change of the snowfall. So we have 18 and we have 7. Obviously, you can see this went down. My original number was 18. My new number was 7. So we're going to find the difference, and I'm going to do it in order. So we're going to subtract these two. Now, it doesn't really matter which order you do it in, but I'll show you. This is the way I would do it. I always like to take the new number and subtract it from the original number. I'll show you what happens if you don't do that. It'll still work out. You just have to kind of be aware. But the original number in this case was the year 2000. It was the 18. So you're going to divide this by 18. And you're going to get a decimal, hopefully. I mean, that's what a percentage is. You'll just have to convert it. So 7, you're going to go 7 minus 18, which is your negative 11. Divide that by 18. In this case, I'm going to get negative 0.61, which equals, in this case, it's a percent change. Because I had the negative, I know I went down 61%. Now again, I said this a minute ago, it doesn't matter which order you subtract the numbers in, but if you went 18 minus 7, you would have had a positive 11 over 18. So you'd get the 61%, but you'd have to then realize it went down. You'd have to kind of know that yourself. The negative here kind of tells you that. That's why I always like to take the new number minus the original, because that way the negatives kind of just pop into the problem. And if you see the negative, you know it went down. If you see it's the positive number, you know it went up. But like I said, in the end, it won't matter as long as you're paying attention. Okay. I mean, that's percent change. It's nothing too crazy. Same thing here. What I'll do is I'm going to give you just, hey, let's do this for a second. Let's take a minute, solve this, and then we're not going to do a poll here. Type in your answer. This is how I can tell if you're participating. So let's do this for just 2 minutes. Remember, subtract the two values, divide by the original. Let's take just a moment to work that out. As you do that, I'm going to take the batteries out of my calculator and see if I can get it to work. Like I said, when you're done, just type your answer, whatever you got. You can write it as a decimal form, but what we'll normally want to do is convert it to a percentage. It's a big percentage. If you're having a hard time, type that in as well so I don't wait forever. Oh, that's good. What I'll do is I'll go 1 minute, unless I get a hard time for everybody. Okay. Now, with Lena, I know exactly what you did, so I'll talk about that as I go through. The answer here should be 475%, and here's why. All right. What you're doing, you think of it this way. This is the first number. This is your original number. It's the year 2000. And I say this would be, I guess you call it the new number. What I need to do is I need to find the difference between these two. So that when you're doing percent change, you're doing the difference. The years don't really matter. In this case, the difference would be 23. I always do new number minus original. Again, at the end, it won't matter. Just, you get the same decimal. Just it'll be positive or negative. You have to figure out what it should be. But here I get 23 minus 4. Now the original is 4. Oops, I have that timer set. Original is 4. So we're dividing by 4. I think with Lena, you probably divided by 23. So that's how you're going to get your 82.6. So you divide by the original number, not the new number. So if you do that, 23 minus 4 is 19. Divided by 4 is going to be 4.75. All we need to do to convert that to a percentage is we're just going to take that decimal point and we're going to move it 2 spots to the right. Or you do the opposite of when we have a percentage, you divide by 100. If you want to convert it to a percentage, you multiply by 100. But this is going to be 475%. Yeah, let me know if that's making sense or not. We can always do some more here as we wrap things up. Now with the decimals, just that question, just in general, like if you had like 0.6 or 0.25, these are some other decimals that you would have, this would be equivalent to 60%. And stuff, just trying to relate it to something that we dealt with a lot before. Actually, I'll even set this up. Let's say you took a quiz at school and you had a 6 out of 10. Well, the teacher's going to give you a 60% on that quiz. That kind of sucks, but it is what it is. But what you would get is you get 0.6. That's the decimal. To convert it to a percentage, which is, again, that'd be a 60%. Yeah, no, you can't see. Oh, yeah. Okay, you move it two spots to the right. So I'm just doing the same thing. Okay, so that's percent change. Like I said, if anything else, you can always go back and review the recording when I'm done. I'm going to kind of set up. I'll email you guys and set up where I'm going to put it. I think I'm going to put it on my website somewhere, or I'll just do like a private link on YouTube. But I'll get this video to you so you can watch it. Okay, next up, two-way frequency charts. So when you deal with the SAT and you deal with the two-way frequency chart, you're basically doing probability. So that's where we need to start with this. A two-way frequency chart is just a scenario where you can do probability questions. So probability is just this, and that's another kind of formula thing you need to know. You know how to find probability. It's desired outcomes. So what am I looking for? How many scenarios would fit what I want? And divide that by the total amount of possible outcomes that you could possibly get. That's the formula. They like to test them, not like to, they love to test them with frequency tables. A frequency table is just a bunch of numbers which you can add up horizontally and vertically. So this is a frequency table. So in this case, all I would need to do before I even start looking at the questions below, I got to fill this chart out. So what that means is I need to add up all my totals. So For instance, my apples, this column right here, I add these numbers up. 19 plus 22 is 41. 12 plus 9 is 21. 23 plus 15, that's 33, 38. You're just adding all these up. That's what you need to be doing. Just add these up, and you can kind of do the different rows right now, and then kind of check your answers with mine. I'll do it slowly so you can get ahead of me. But I'm going to find these three totals. Okay. So the first one, what you should get, you add those three numbers up, you should have 54. Next up, my 10th graders, I should have 46. And when you do your final total, you can add it up either way if you're not sure if you did it right. This vertical sum should be the same as this horizontal sum. So it really shouldn't matter which ones you do, but it should fit no matter what. So yeah, I get 100. And then just double check, 41 plus 21 plus 38 is 100. So you get 100 either way. So that should be what you're getting. If you're not, you probably just messed something up with your addition. Typed a number in wrong, or just did it in your head wrong, or whatnot. But you got to have those numbers. Without those numbers, you cannot do the probabilities, because you won't know what the desired outcomes are because you won't have the numbers, or you won't know the total possible outcomes because you won't have the numbers. But now that we have that, we can start solving. Okay, so these are all, again, as I said, probability questions. You got to fill the two-way frequency chart out to get there, but now it's just this formula up above. That's all it is. So at this point, we have one ninth grader that's going to be chosen at random. So I look at my ninth graders, I have 54 of them. So out of those 54 students, that's important to note. Okay, in this problem, number one, I'm dealing with 54 students, not 100, out of the ninth graders. That's going to be my total possible outcomes right now, without even reading the rest. 54. Why? Because there are 54 ninth graders, and that's what I chose from. The other ones don't matter. What is the probability that ninth grader would prefer either apples or oranges? So what's the probability I'd get one of those two? So my desired outcomes would be either one of those. It doesn't matter which one. So what you need to do in this case is you need to take apples and oranges, 19 and 12, and add them up, because that's how many desired outcomes I would have. So that would be 19, 29, 31 out of 54. Again, these are your desired outcomes. These are your total outcomes. You just got to find out what those numbers are, and then you divide. Now, a probability is basically a percentage. Sometimes it's just written in decimal form on the SAT, so I'm going to write it in both forms, but it could be either one. So 31 divided by 54 is going to be 0.57. If they just have the decimal on the SAT, then just write that's your answer. Or you can write 57%. Move the decimal point over 2 spots. And that's really all you're doing. If you see a two-way frequency table, this should be your mindset. It's just a probability question. Fill out the table and then do the probability. Okay. I will erase these because we're going to have a new set of data for this next one. All right, so number 2, we're going to do the exact same thing. I think number 2 is a little tougher, but other than that, it's the same. I have a student who preferred apples or bananas. So again, that is where my apples, bananas, this is going to be where I pulled my data from. So I'm going to look up here. My apples, I had 41 students here, and my bananas, I had 38 students here. My total is going to be these two added up. These guys, these 21 students, were not counted. That should be 79. Just double checking all that. Yep. There's only 79 students in this poll that I guess we're doing on number 2. Again, out of 79 students is what that first statement should say. Out of those 79 students, what's the probability that that person would be a 10th grader? So again, look at this column and this column. I'm looking at these two columns. The other one don't matter. This column doesn't matter either. It's just, that's the total of all of those three. Out of those two columns, how many students are 10th graders? So I'm looking at the 22 and the 15. That's my desired outcomes. So that's 22, 32, 37. So here I have 37. That's my desired outcomes. Those are my 10th graders from those two columns. Divided by 79. That's going to be my total possible outcomes. So here I divide those, 37 divided by 79. I get 0.468, I'll call it 0.47, or 47%. That's the probability that I would get one of those students from that list. So the first thing you really need to figure out on these problems is, what's your total possible outcomes? Where am I pulling my data from? And that's what you have to do with these frequency charts, because sometimes we're not including, like in this case, we weren't including the students who preferred oranges. They weren't even a part of this survey. So you get rid of those and say how many you have left. That's your total. Then from that list, from that subset, you need to figure out what your desired outcomes are. In this case, it was the number of 10th graders. Okay, so that's really what, for the most part, I would say a lot of these probability ones are mostly easy to medium level questions. They're much harder ones. You just have to kind of get comfortable with finding the proper numbers, because that's really the only way you'll mess this up is you pick the wrong numbers. So just be careful on those. Okay, that's all frequency tables. That's really all they're going to do. Again, if I go past something and you're like, hey, I had a question on that, stop me. But otherwise, I'm moving on. I'm going to go down to our last set of things. We have, yeah, that's our last set. So I just have 1, 2 here, and 1, 2, 3 here. I'm actually going to do the average pi last. It's just I want to jump to do something a little easier, number 24, and then I'll save the best for last. So page 24, I'm going to go to the bottom of this page, and I just want to talk about mean, median, and range. Just general, just finding averages just for the most part. And just make sure we're good at these and move on and get to the fun stuff. And that's where we're going to wrap up today. So basically what we're going to do on these sets of problems, I just want to make sure we're good on these. Most of this should be stuff you've learned in like middle school. But we're going to find mean, median, and range. And I just want to make sure you're good on this. Now the thing with means, all you're really doing to find a mean, and I have it, this happens, I jump back and forth, but a mean is an average. So I say find the mean, you're finding an average, and this is your formula. Find the average of a set of items, you add them up and divide by the number of things. So if I was going to find the average of these two sets, I'm going to do means first, both of them, then I'll do both the medians, and I'll do both the ranges. I'm going to do that. So for this first one, I'm going to find the mean, and all you're going to do is you're going to add up all those numbers. If you add them up, make sure you get what I get. I'm going to add 47 plus 49 plus 54 plus 50 plus 48 plus 47 plus 55, and I get 350. And then you're going to divide by the number of things. So in this case, I have 7 things. So you're going to divide those two numbers. That's going to give you the average. In this case, the average would be 50, which is the mean. Add them all up, divide by the number of things. Again, that's stuff you probably learned a long time ago. If you forgot it because you haven't used it in a while, it's probably something you're going to be like, oh yeah, I remember that. Number 2, do the same thing. Doesn't really change, other than the number of things. I guess there's 6 things here, not 7. But here, just add them up. 70 plus 74 plus 72 plus 71 plus 73 plus 96. In this case, if you add everything up, you should get 456. Divide that by the number of things, which is 6. This one probably won't be as pretty, and actually it is, never mind, it's pretty. You get 76. Now when you find an average, again, it should be somewhere, it should kind of be close to these numbers. I mean, 96 is sometimes what you might call an outlier. It's a little higher than the numbers. If you have an outlier, it may kind of skew your results. But as you can see, 76 is kind of where all these are at. If I had like 9,600 and something, my answer would probably be way higher than 76, because that number is going to like really change my average, but you should be able to kind of get an idea. Like 50 looks like it's pretty close to those numbers. It's the average. It fits. Okay. Next up, we'll do the median, and then also the range. Now for these next two, you need to have, and I'm going to put the note up here. In order to find any of these, I'm going to put the numbers in order. I don't care how many numbers there are. If they're asking you to find a median and a range, you got to put them in order to find it. So in this case, I'm just going to start putting these in order. Now it looks like 47 is the smallest, so I'll start there. I'm going to cross these out as I go. I got another 47 over here. Looks like I got a 48. Then I have a 49, 50, 54, 55. And again, I'll do the same thing for my second set of numbers. So I'll come over here, start with 70. If I went too fast, I'm going to head back to the other one in a second. Then I have 71, 72, 73, 74, and then 96. So I got them in order. So that way it'll be really easy to find the median and the range at this point. Again, mean, it doesn't matter. You just add all the numbers up. It doesn't matter if they're in order or not. So for the median, all the median is, it's the number in the middle. So as I'm looking at this list, what's in the middle? In this case, 49 is in the middle. If you kind of look, I have 3 numbers to the left and 3 numbers to the right, which puts 49 smack dab in the middle. One thing you'll notice from above, if I'm finding a median, it's an odd set, there's one median. If it's an even set, which I'll have in the next one, the median is the average of the 2 middle terms. So that's what you're going to see as I work through these. This one has one middle number. It's very clear. The median is 49. So 49 is your median. However, if I hop over to this other one and I do the median, you're going to see that I have 2 middle numbers. I have 72 and I have 73. Both of those can kind of lay claim to the middle number. Technically the middle's somewhere in between, right? Okay, because I have an even amount on both sides. So in this case, we're going to find the average of those two. So we're going to go 72 plus 73 divided by 2. Or you just pick the number, because the average of 2 numbers, you pick whatever number's in between those two. In this case, that'd be 72.5. Yeah, so you'll do medians with an even set. Because it's an even set, 6 numbers and this 6 is even. You have to find the average of the 2 middle numbers. If it's an odd set, you're going to only have one number that's in the middle. All right, and finally the range. That's your last piece. The range is just going to be the largest number minus the smallest number. So that's why, again, we want to have them in order so you don't accidentally, mix up, whatever the largest number is or smallest number because you didn't happen to see it as you were scrolling through. If they're in order, it's easy to see. We have 55 and 47. I'm going to subtract those two. That's going to give me 8. Done. That's the difference between the smallest and largest values. Come over here and do the same thing. That's going to be 96 minus 70. So that's 70, 80, 90, 26. And because 96 is kind of what is called an outlier, it is a range, even though all the other numbers only differ by 4. But hey, that's what an outlier does. It really affects the range quite a bit. So that's mean, median, and range. I didn't really mention mode. I put it up here. You'll see it in the notes. Modes are just going to be the members of a set that occur the most. So like for instance, 47 would be the mode in this set, whereas over here I wouldn't have a mode because they all occur the same amount. But if one number occurs more than the other, you have a mode. They're pretty easy to find for the most part. They don't really test them. I put it in there again just in case, but they're not really tested too much. Okay, so this will leave me with my last little thing for today, and then we'll kind of wrap up, which we're about on time at 7:50, so we're doing good. So what we're going to do is I'm going to talk about multiple average questions. And for multiple average questions, I use this thing, I call it an average pie. And here is the average pie. And again, it comes from the average formula. And what I want you to see is what I've done. What I've done is I've basically said this. An average equals the sum of your terms, or I'll call it the total, divided by the number of things. And what I'm doing is I'm going to multiply both sides by the number of things. If you're trying to write this down, you don't have to. So I'm kind of going quick. If this is a little bit of algebra here, these would cancel, and I'd be left with this equation. What I'm doing is I'm taking this equation and I'm plugging it in to a pie chart, I guess you can say. So what this says is the following. Pretend like none of this existed. That average pie is basically that equation. Total, or the sum of all your terms, is equal to the number of things times the average. Now the reason why I do this is for what's called aesthetic reasons. As you're solving a problem that involves multiple averages, it can get very confusing very quickly. The average pie, what it does, it allows you to keep everything organized, and it keeps it, again, what's called, it's aesthetically pleasing. You're able to look at a complex problem and it doesn't look complex because you have everything nice and orderly. It's hard to explain it until you see an example, but again, there's a reason this is here. So I have 3 examples here. I'm going to kind of walk you through the average pie and how it works, but this is basically what it is mathematically speaking. And it is normally used for what I call multiple average questions, which means a problem that has more than one average in it. That either you have to add things or subtract things from it. It can normally be very confusing, but hopefully it won't be. The first one only has one average. This is more to kind of get you used to average pies, and then we'll move into our multiple average questions, and this is kind of where we'll wrap up today. So here's what I do. When I'm working on the SAT, for the most part, I always use average pie. I don't care if it's an easy problem or hard problem. If it's easy, then this formula still works. It's just your average formula just written in a pie chart. So it'll always work. So like I said, you can always use it. You don't have to, but you can always use it. So if I see the phrase average pop up in a problem, I'm going to write an average pie immediately and fill in the pieces that they're giving me. So go ahead and write your average pie because they have an average here. They're telling me that 9 is the average. Now, just so you know, because when you multiply numbers, order doesn't matter. If you get these 2 backwards, as long as you're consistent, it shouldn't matter. The only thing that does matter is that total better be that top value. The 2 bottom ones, they can go either way. I really don't care. I'm going to try to stay consistent with the way I have it written. So I'm going to put my average on the left, or on the right, I mean. So 9 is the average. Okay, now they're saying it's the average of what? X, 4x, and 2. That represents the number of things. X is a thing. 4x is a thing. 2 is a thing. There are 3 things. And here's what the average pie is going to give you. The sum of those 3 things is 27. This is useful because I can now do this. I can take these numbers, add them up, x plus 4x plus 2, and I know it equals 27. Notice they never gave me that. You know, they didn't say the sum was 27. You had to figure that out, and that's what the average pie will do for you. It'll just give it to you. You see the word average, you just write down what they're giving you. They gave you an average. They told you that there's 3 things. The 27 just appears, and you're like, oh, that's actually useful. And now you set up an equation. You can solve. You can do your math. This is going to be 5x. You combine like terms. Plus 2 equals 27. If I subtract 2 from both sides, I get 5x equals 25. Divide by 5, and x is going to equal 5. And they wanted x, I got it. So average pie is kind of useful, okay? And that's a problem where, again, you didn't technically need the average pie, but it still makes it kind of neat. It's kind of easy to see because it kind of just solves itself in a way. But like I said, that's not why I did average pies. If that's all we really saw, I wouldn't be teaching average pie. I would just teach this scenario and would be fine. But there's other scenarios, and that's what number 2 is all about. And number 3. This is, like I said, we're going to wrap up. So this one, we have a class of 15 students, the average test score. I see the word average. I'm going to write an average pie. So I'm going to fill this out. Just stop reading. Just fill this out. A class of 15 students, so 15 things. The average score is a 78%. By the way, as you fill this out, you can either type 78 or 0.78. It really won't matter in the end, as long as you're consistent. You can't call one 78 and then the 75% call it 0.75. Whatever you pick, just be consistent with it. I'm going to use 78. So I'm going to go 15 times 78 is 1170. So that's the sum of all the scores if I added them up individually. Now, this is where it gets a little tricky, so follow me. 2 students joined the class and took the test. Okay, so here's what's happened. I'm adding 2 things. What you'll see at the end, they're going to say, what was the average score of those 2 new students? So I don't know what the average was. If I don't know the average, I don't know what that total was either. I only know that there's a 2 there. That's it. And I know that's being added to my 15 students. Okay? This is the template that you're going to see when we do multiple average questions. It's going to be an average pie plus or minus another average pie equals the combined averages. In this case, 2 students joined the class and took the test, and the class average then dropped to 75%. So what they're telling you, if I added these 2 values together, I'm going to now have 17 students, 17 things. My average is now going to be a 75. Notice what you can do with this. If you have this new average pie, you have a 17, you have a 75, you can get the total. You just have to multiply those together. So I'm going to do that. 1275. And there's your setup. From the setup, you can actually find your average. I want you to take a look at this real quick, and then I'm going to do it. Okay, so what we have now is we have these totals. I know this total plus whatever this total is. I don't know what it is, but I do know if I add them up, I should get that total. That's where the aesthetically pleasing part comes into play. It all lines up. Okay, I know 1170 plus something is going to equal 1275. So go 1275 minus 1170, and you get 105. So the next question that you have to ask yourself is this, and this is the last question because you're about to solve it. I'm going to go 2 times this some number. That's going to give me 105. So 2 times, you can call it the average, that's what it is, right? That equals 105. So divide by 2, and you get, for your average, 52.5. And that is the average of those 2 new students. And the 1275, just so you know where I got that, it's 17 times 75. We knew that we had 17 students when you add those 2 together. They told us in the question itself that the average was now going to be a 75%. So I was given those 2 numbers. I just had to multiply them together to get the 1275. Okay? And you'll see me do it on this next one as well. Number 3, pretty much the same problem. The only thing you'll notice here is I'm going to be taking students away. They're dropping the class instead of being added. So it's a very, 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 very similar problem, except this will be a minus sign. Okay, so understanding the concept will be the same here so before you even start. So anything that you missed last time, you can kind of hopefully get it this time. So here we got a class of 30 students, took a quiz, and they received an average of an 82%. So let's write this out. We have 30 students in the class, so 30 things. The average is 82. And remember, if they give us those two bottom numbers, we can get the total. 30 times 82 is 2460. All right. Now we had two students drop the class. So that now I'm subtracting two students. Remember, I don't know anything about those two students yet. I figured it out, but I don't know anything yet. Here's what I do know. When I take two students away, I'm going to be left with 28 students. Okay. Now, two students dropped the class. The average changed to a 90%. So the average of those 28 students is now a 90. Again, they're giving me that number. So let's multiply those two numbers together, 28 times 90, and my total is going to be 2520. Just like the problem before. I have a total minus now, that's the difference, some number, and that's going to give me 2520. Okay. Did I do that right? Maybe my numbers are bad. Two students dropped. Okay, so right now with the numbers that I have, I'm actually going to get a negative. I don't want a negative. So I'm going to change the value in this problem to make it not turn out that way. So let's backtrack real quick and let's change this 90 to 84. So just do that for me. I just don't want a negatives. I wouldn't really, I mean, it would still mathematically solve, but it wouldn't really make a lot of sense. So I'm going to change that new class average to an 84. So cross this number out, call that 84%. That's where I'm getting that number from. And let's remultiply that to 2352. That's better. Okay. So now we'll get realistic numbers. So here's what's going to happen. I'll go 2460 minus that, whatever that total is, equals 2352. So we just need to get the total on one side, and let's call this total if we want t. So it's like solving a little equation. You can kind of do it in your head if you want. Technically, I'm going to add t to both sides. I'm just showing you the actual math. So I get 2460 equals 2352 plus t. And then it's going to go 2460 minus 2352. So I get 108 equals t. So that's my total up here, 108. So just like we did before, 2 times the average should equal 108. So divide by 2, and you're going to get an average score for those two students who dropped of a 54. Maybe that's why they dropped, because they failed, I guess. And that's average pi. I'm 4 minutes over, but that's 4 minutes where my computer stopped working. What I'm going to do right now is I'm going to kind of just give you your assignment for next week. This is what we'll review at the very beginning before we start anything. What we have is 2 pages here that we need to be aware of. The first one is page 15. I know we started this. I'm going to email out just the answers to you guys. So as you're working through, you can kind of see if you're getting it right or not. So we're going to do page 15, and that won't take too long, I don't think. And then the next one that we'll have for next week is page 27 through page 27 through 30. So we have 28 questions here. What you'll see, like you'll see find mean, median, range, each set of values. You'll see these 2 questions, which are your probability questions. You'll see these are average pi questions. They're going to line up with the notes fairly well. So kind of follow the notes as you're going through. If you're getting stuck on any problem, let me know. What I do have two sets of problems that you might want extra help on. These 18 and 19 on page 29. These could be a little tricky. I'll probably go over those, but try them. And obviously these two, because they're bonus. I call them bonus because I didn't go over it. But and it hasn't been on an SAT yet, but it might be, so I want to at least talk about it. So if you have any questions, what we'll do is I'll hang out. If not, you can just log off. I won't be insulted. Just again, understand. Okay, the homework. Just so you know, it's page. So homework. We have page. Well, this one's 27 through 30. And again, it's the stuff that says homework. So just look in the book where it says homework. We had the math basics and the arithmetic lessons that we did today. So page 15. So it's page 15 and then 27 through 30. I'm just going to write it down so you have that. So page 15 and then 27 through 30. Okay. So yeah, like I said, just you're going to be working through those. I'll email you the answers. Again, it'll have no work because I don't want you just copying it. I want you to just kind of check your work. And then what we'll do next week, first thing, and what I'll probably do, I'll probably log in early. So if you want to come in early, I mean, I may not be at the computer, but I'll just open the room. I'll have the file so you can share it. You can kind of look over your homework questions with all the work, all the work loaded. And then once 6 o'clock starts, I will see what questions we have. Okay? So if you got anything else that you want to ask, you can do that now. If not, I'll see you guys next Thursday. You can always text me. You can email me. If you have any questions, just let me know. Okay? Thank you. You guys have a good night. Okay, I'll hang out just a second and help you with question 7. That's fine. So number 7 says 17 is what percent of 34? So you go 17. That's 17. 17 is means equals. Remember this what percent is that special phrase. It always means x over 100. So you're going to go x divided by 100 of 34 is times 34. This one is just a little tricky, I think, in the solving of it. So I would maybe do this. I would do it in one step, but I don't want to throw you off, so I'm going to do it in 2 steps. We need to get rid of two values, the 100 and the 34. So I'll get rid of the 100 first, and I'll do that by doing the opposite operation. It's being divided by x, or divided from x. It's going to multiply by 100. And I know I know the answer, but I'm going to type it on the calculator, so I got it ready to go. So that's going to give me 1700 equals x times 34. The 100's gone. And then next, I'm going to take both sides and divide it by 34. I'm going to divide that by 34. You get 50. If you wanted, you could have, at the very first step up here, you could have multiplied by the reciprocal and done it in 1 step. But, you can do it in 2. It doesn't hurt. But that's what you do there. Number 7. No problem. You have a good one.